So let's continue. Let's talk a little bit about some previous studies. I can already feel I'm not going to finish this full class today, but I will try. So this is a study from 2003, and the reason why I say that so with such emphasis is that it's pretty impressive that they already knew these things. What is it? 7, 8 years ago, 8, 9 years even. So what they say is that 74% of variation in defects are explained by whether projects used early prototypes, design reviews, and integration regression testing on each build. So that's incredible. They saw such a strong relationship between early prototypes, design reviews, and integration and regression testing. So let's quickly talk about each of those three. Well, early prototypes we have a pretty good picture of. So every once in a while show the product or show a mock-up or show something to the customer so the customer can click through it and go, not quite what we're going for. Design reviews is pretty similar, but of course that's where developers can go, I like what you've drawn here, but it's never going to work in reality. Or, as you put it right now, performance is going to take at least 7 seconds to present a result on Google. And that's not, we can't do that. 7 seconds is way too long for any customer. And number 3, can anybody tell me what integration and regression building is? So in a large software company, if you have different teams working together, you can already imagine that if they have to deliver a project together, that they're working in their own separate units. So for 1 week, let's say half the room will be working on one unit, and the other half of the room will be working on another unit without communicating. Well, let's say that this unit and that unit, or this component and that component, have to communicate, and maybe at some point this unit had to decide, well, we have to make some design changes, and didn't communicate it to the other unit. So you can imagine that I've actually been involved in a project where we worked separately all the way up to the end, and we had about 2 weeks to put everything together. And in the end it took 6 weeks, simply because we didn't know how many complexities there still were with the connection. We hadn't really found a way to coordinate all the different components and how they had to talk to each other. So that's something you really have to keep into account. So doing this on each build, and it's really hard. It's really hard to make sure that the full product works well every period, or every month, or every week, or every whatever. Because, well, it's a lot of time to put them all together, to test it. And of course you want to automate it as much as possible. But that's a discussion we'll be having later. So here you see some nice, so releasing prototype earlier than median functionality, 27% reduction in defect rate, and 35% rise in lines of code productivity. So that basically means that developers write 35% more code when you use prototypes. So that's a pretty good one. Here also, integration regression testing at each code checking. So that's whenever somebody says, okay, now I finished my work for today, or I finished work on feature number 1, now I will commit it to the code base that everybody commits to, where all the code is collected. And if it immediately does integration regression testing and shows, hey, this and this is not working, then those mistakes will not turn up later, and that will save time with the other developers. So here's obviously a lot of time that can be saved. Design reviews, 55% reduction in defect rate. That's incredible. So that basically means developers getting together, put them in a room, have them comment with their red pen on design documentation. Can save you 55% defects. And I can tell you, every customer that has to enter a defect, or every tester that has to enter a defect, with every defect they get more and more annoyed. So they get more annoyed, more pissed off, and they get less and less satisfied about your development process. And very important, daily builds. So this is something that's, especially in a web project, not so relevant. But if you're working with Java or C or whatever, you have to build, or you can build a version every day. And the good thing about that is that, of course, at the end of the day, you have a working prototype that you can show to a customer. Or you can even say, hey, yesterday I built all this and this in, but I'd like to get some feedback from the customer before we deliver by the end of the month. And that, of course, again, speeds up the cycle. So here you can see 93% rise in lines of code output per programmer. Well, that's, again, incredible. I think I already told you that for some languages, especially more advanced languages, lines of code output is about 10 lines per day. And that's really very little. I think most of you, if you sat in the room today and worked for the whole day, you could probably put a program together with maybe 200, 300 lines without too much problems. But it's not, when you start talking about a larger product, well, out of those 300, maybe you have to change a couple, then add some, remove some, and in the end you come down to 10 lines per day. Let me see what I want to say. Yeah, so here you see a nice combination of different techniques you can use, for instance, sort of to prevent the waterfall problems. So short development subcycles, early prototypes, frequent builds to incorporate feedback and changes. One thing that I've noticed with customers is that if they see progress constantly, they're happy. But if a customer sees that, hey, I said change this and this and that, and it wasn't changed, then obviously the customer gets more and more annoyed. Well, design code reviews, regression tests on each build. One thing that's not in here, but that sort of shines through, and that's something you should know as well, is that developer productivity can vary with about 1,000%. So if Joey is our star programmer, he will produce maybe 100 lines per day, and I'm, as you may know, a very weak programmer. I make many mistakes, my code is crappy, and I can only produce 10 lines per day. And that's an acceptable difference. So at the end of the year, we will see a report, we will just see that Joey is such a more productive programmer. And if you look at what he programs, maybe he's just a better coder, maybe he makes more mistakes. So maybe my 10 lines of code are perfect, and his 100 lines are very buggy. Maybe he just has so much more experience and was the first guy to be on the project. So there's all these factors that come into play, and this is acceptable. Of course, if I'm also making lots of mistakes, being complaining a lot, then you can see that my boss will probably fire me pretty soon. But this is still acceptable. This happens a lot. So one thing that is in here, in point 4, if I look at Joey's code frequently, I may pick up a thing here or there. And if he looks at my code and constantly says like, Slinger, I like what you do here, but maybe we can change it a little bit. Or what you're doing here is good, but you're maybe doing the wrong thing. Let's take a nice example. So let's say you have a system. So this is a real company. You have Microsoft CRM. Who said business-based? The answer is right. Here we have Microsoft SQL Server. And here we have our add-on product. Now let's say Joey is programming something, and Joey will say, okay, we're maybe doing time registration. So he's making a nice time registration component. And when he builds it, he says, okay, my time registration component talks to the add-on talks to Microsoft CRM, and this then gets the data from the database, and well, that's sort of the clean way of doing it. Then the Slinger comes by and he starts programming something here, and he says, well, I'm making a nice little form, but I think this is a bit too long, so I'm going to talk directly to Microsoft CRM, because I don't want to go through the add-on. By doing this, I maybe gain some performance, because it's going a lot more quicker. I don't have to go through the crappy code, and I can talk directly to the API. And then Joey can say, yeah, I like this convention, this is a good convention. So this is also an example of architectural erosion, because the architecture prescribes this, yet instead I'm breaking through it. But I managed to convince Joey because he sees my point, and he sees that going through here is a lot harder, and we need to make changes to the add-on. Well, it's a lot of trouble. Now, let's say Kirsten is also joining it, and Kirsten has to draw a form, and she sees that this is quick, but this is much quicker, going directly into the database. Now you can already imagine what the downside of this is. If Microsoft CRM updates, then all you have to do is update this link for Joey's link. For me, you also have to update this link and this link. So basically I have to introduce extra work into the project. And for Kirsten, I mean, she probably has to rebuild this completely. Because Microsoft CRM might have changed their whole data model in the meantime. So, well, this is a nice example of architectural erosion. It's a nice example of doing code reviews and saying, I don't like this at all, I don't like what you're doing here at all, or maybe this is a bit old-fashioned and we should do it more like this. And it's these kinds of decisions you need to talk about. And regression tests on each build. So again, we go to this example. Whenever we do a build, we have to build this component, this component, this component. See that if I do something here, it changes here, it changes here, it changes here. The test of everything is still working perfectly. All right, so here's some advice from 2009, also from IEEE software. So basically today we're talking about lots of IEEE software articles. And my paper was also in there, maybe even in the same edition as this one. So here they looked at critical decisions for startups, and they said, well, one of the first things you need to do is process instead of product design. So typically, if all of us get into a room for a startup, we will all start thinking like, okay, what do we want to build? How do we want it to work? How quickly do we want it to go? And what they're recommending is don't go for the product. So don't think about GPS, think about maps, think about locations. No, start thinking in another way. Start thinking, okay, how are we going to develop? What happens if a big change comes in? Because the decisions we make now will help us for the next 2, 3, 4, 5 years until a big process redesign happens to deal with changing requirements. It's not something that I think every company does. Most startups will not start like this unless you have a large team. So it depends on the project context, obviously. With high market uncertainty, well, iterative prototypes and beta releases. Platform technology uncertainty, focus on building an adaptable architecture. I think you can see why these two are in there. So if the market is uncertain, well, you want to be able to constantly rework and implement new requirements and, well, do your best there. Whereas if you're not sure that you can deliver search results within under a second to the whole world, like